Hi, my name is Zane, and today I'll be talking about variation in length of Little Brown Bat Myotis lucifugus from museum specimens across a latitudinal range in the Northwestern United States. And to start off, like to give a little precursory information about the little brown bat. The little brown bat is, of course, a flying mammal that inhabits most of the northern United States and southern parts of Canada. This species has historically been quite abundant across all of these ranges, but has recently become more of a conservation concern on the onset of various diseases and such. This species typically has a length of about 76 to 95 millimeters long, and this can vary significantly between the sexes, as this is a sexually dimorphic species. The females often serve to be the larger of the two sexes in this particular group. And what's interesting about the little brown bat is there is an abundance of information about it locally. There's been a lot of different research papers over the variation of the little brown bat sizes within given states. However, where the research is lacking is actually how these different sizes will compare between different states rather than within them. And so I thought it would be an interesting assignment to look at how the sizes of these bats might change over a latitudinal range. And that is represented in this research project by looking at different states in the United States. And any significant differences between these sizes could indicate perhaps some kind of speciation or some adaptations being put in place that could serve as an interesting starting bit of information to jump into further research in the future. Now, for the sake of data collection, I used VertNet, which is an online collective of a bunch of different museums that contain different specimens of, in this case, the little brown bat. And what I looked for is different specimens that had recorded total lengths. And these specimens would be from the time of 1980 onwards, as that sort of cuts down on the different generations and any significant changes that might have come through, progress over time. And the locations that wanted to look at to assess more of that latitudinal range starts up in Alaska, Washington, Wyoming, and Colorado. These locations did have a rather large amount of data, so they were kind of ideal for this sort of study. And you can see the obvious top to bottom look at these different states. When looking at the data, there was a lot of unnecessary data removed or any data with error. In this case, some unnecessary data included those that did not sex the specimen itself. Since they are sexually dimorphic, I had to look into how sex was actually affecting along with the latitudinal range for the sake of consistency. And there were some that said they were thousands of millimeters long, which is obviously a typo error, and I couldn't bring it upon myself to fix that. So they were just simply removed. And at the end of this process, there were a total of 533 specimens that were used in the further data analysis. And so for the analysis, two-way ANOVA was performed. And what a two-way ANOVA does essentially is it compares the different states, the bats within certain states across one another. It looks at also the sexes and compares those across each other to see if there's any significant differences in the variation. And it also looks at an interaction factor and how both the state and the sex might interact with one another and how that might significantly differ between the groups. And the total length of these specimens was compared using those methods. It was found that the data pulled from was actually non-normal. And so to sort of rectify that and solve that issue, a randomization test was performed, which is a typical process used to solve those kinds of issues. And to do all the calculations, I did use RStudio in the latest version. And what I found with that information was produced here. And this is a lot of different information. Along the y-axis here, you have the total length, and across there you have the different states and the sexes. So each group is divided by state and by sex in their own little box plot here. And what was found is that all species in Wyoming, which are represented here and here, and the Alaskan females were significantly different from every other group, that meaning they were significantly higher than others. One anomaly did actually come from the Washington females, which served as similar to the Wyoming males and had a bit of a data anomaly in that case. So didn't really know how to handle that. But the Alaskan and the Wyoming species were by and large greater than the rest of the other species in terms of total length. They did have a significant difference. And what exactly does that mean for this? It is a significant result, but it's not really indicative of any kind of pattern. Because if we go back here and look at it, there were the Alaskan females that were significant, as well as all of the Wyoming species were significantly larger than the Washington and Colorado, which doesn't really fit any sort of trend as far as latitude is concerned, because if we were to see something that suggested latitude did have some kind of effect on these species, then Washington would also be significantly different than those below it. However, that was not the case in this scenario. So it's not really fair to conclude that latitude has any sort of effect on the species. Rather, I looked at maybe some alternative hypotheses, and these are purely speculation, as there is a lack of research within these across state looks at the bat species. But what I thought is it could be more local environment dependent, rather than looking at the latitudes themselves. Looking within a given state could have more significant differences on how the bat lengths change, rather than any sort of range type of deal. So the local environment could have greater impacts on that. There could also be some differences between the bat's mutation or adaptation rate. Say some are faster to pick up, or rather will become larger as generations go on at a quicker pace due to some genetic differences. Or it could simply also be sampling bias. There was a slight disproportionate amount of data in each given state, and so I would put forward that more data is really needed to get a larger assessment of this. It would be great if there was an abundance of data sampled from every state that could be pulled for them, that could give more of a thorough interpretation of what all this means and what it could step forward to. But as of right now, working what we have, there doesn't seem to be any effect that latitude does have on the total length of the little brown bat. And I would like to thank my partner in this, Micah, who helped with a lot of the writing, data analysis, and filling out all those different portions. I'd also like to thank Dr. Foray for just giving the chance to present this, as well as Dr. Hudman, who actually helped me figure out all the randomization tests and how to run those in R, which was rather new to me. So it was very helpful. But that was the presentation, and I hope it was somewhat informative.